First type of moon missions is flyby mission. A flyby mission is typically referred to a space mission in which spacecraft flies around the moon without entering into orbit or landing on its surface. Flyby missions are often used to gather data, take photographs, and conduct scientific observations without the need for the spacecraft to remain in the vicinity of the target for an extended period. Second type of moon missions is orbiter mission. In orbiter mission, spacecrafts complete their revolutions around the moon and make orbits. Such orbits are called as lunar orbit. In this way, they study the surface of moon and its atmosphere. Third type is impact mission. The term impact mission on the moon typically refers to a mission where a spacecraft or a component of a spacecraft intentionally crashes into the lunar surface. These missions are designed to study various aspects of the moon, including its composition, surface properties, and potentially the presence of water ice by analyzing the impact and its aftermath. Next type is lander missions. A lander mission on the moon refers to a spacecraft designed to land on the lunar surface and conduct various scientific experiments, technology demonstrations, or other objectives. Such landing is called as soft landing, and the component which lands is called as lander. Next type is rover mission. A rover is a small mobile robot that scientists send to moons and planets to land on their surfaces and explore them. Rovers can take pictures and collect information about the planet by taking temperature readings, rock and soil samples. Last type is human mission. Humans were landed on the moon in 1969 to 1972 by NASA. It is the mode of transportation that took astronauts to the lunar surface. Neil Armstrong became the first person to step on the moon on July 21, 1969. On 22nd October 2008, India has launched Chandrayaan1 mission, due to which ISRO was declared the fifth national space agency that landed on the lunar surface. After reaching the moon, this spacecraft has found something very crazy and unique, due to which world was amazed, because none of the space agency has discovered such wonderful thing, and that was water on the moon. Chandrayaan1 has provided the first solid proof in front of the world that water is present on the moon, especially that it exists on the south pole of the moon. That was confirmed by NASA. After hearing this news, whole world again becomes super excited to explore the moon. The vehicle launched for it was PSLV C-11, that was Polar Satellite Launch Vehicle, and the weight of spacecraft was 675 kg. The total amount of expenditure spent on that mission was 386 millions. There were total 11 payloads used for Chandrayaan1 that were exported from Germany, UK, USA, etc. But 4 Indian payloads were also involved. First was terrain camera, second hyperspectral imager, third high energy X-ray spectrometer, fourth moon impact probe. This spacecraft has to expand its orbit gradually by revolving around the Earth. On 8 November 2008, it was entered into the moon orbit. When this was passed at the height of 500 km in moon orbit, then it was projected into stable elliptical orbit. The period of this orbiter was about 11 hours, and after that, it revolved continuously in the moon orbit. On 14 November 2008, Moon Impact Probe was separated from spacecraft that began to fall on the surface of Moon with a speed of 6,100 km per hour, and after 25 minutes it was collided to Moon fastly. It has found iron, magnesium, aluminium, silicon, etc. It completed the 3,000 orbits around the Moon and also provided 70,000 Moon images. On 28 August 2009, Chandrayaan1 has stopped the communication with ISRO, but after 7 years, in July 2016, it was relocated by NASA. Chandrayaan2 is the second lunar exploration mission of the Indian Space Research Organization ISRO. It is an ambitious follow-up to the successful Chandrayaan1 mission, which was India's first lunar mission and was launched in 2008. Chandrayaan2 was designed to build upon the knowledge and data acquired during the Chandrayaan1 mission and to further explore the moon's surface and its composition. Chandrayaan2 was launched on July 22, 2019 from the Satish Dhawan Space Center in Sriharikota, India. The primary objective of the mission's orbiter is to study and map the lunar surface, lunar exosphere, and help to create detailed 3D maps of the moon's topography and mineral distribution. The lander was known as Vikram lander. Its objective was to make a soft landing on the lunar surface near the South Pole and to conduct various scientific experiments. The rover was named as Paragyan rover. The rover was designed to operate on the lunar surface, analyze soil samples, and transmit data back to the Earth. But, unfortunately, the Vikram lander did not achieve a successful soft landing on the moon as planned. It lost communication with mission control during its descent in September 2019. As a result, the Paragyan rover was unable to be deployed. While the lander and rover faced challenges, the orbiter successfully entered lunar orbit and continues to operate. Question arises, why Chandrayaan2 fails? Chandrayaan's 2 mission to soft land on the moon's surface did not go as planned, and the lander encountered difficulties leading to its failure. The primary reason for the failure can be attributed to a combination of technical and communication issues. Here are some key facts that contributed to the failure of landing. First was communication loss. It was supposed to touch down on the lunar surface. This loss of communication prevented real-time monitoring and control of the landing process. Next was the navigation and guidance challenges. The landing process involves a series of complex activities, including reducing the lander's velocity and aligning it with the landing site. Any deviation from the planned trajectory can lead to landing failure. It's possible that navigation or guidance systems encountered issues during descent. Third challenge was altitude anomaly. Reports from ISRO indicated that lander experienced an altitude anomaly, meaning it deviated from its expected descent path and altitude profile. This could have been caused by a variety of factors such as sensor readings or software errors. Next challenge were rough terrain. The chosen landing site for Chandrayaan2 near the lunar south pole presented a challenging and uneven path with large boulders and craters. Landing in such terrain requires precise controls and adjustments, and any misjudgment can lead to a landing failure. Fifth challenge were time constraints. The descent phase is time sensitive and corrections must be made quickly if any issue arises. If the lander encountered a problem and failed to respond in a timely manner, it could result in a crash landing. The sixth challenge was software glitch. Software plays a critical role in controlling the descent and landing process. A software glitch or anomaly could have disrupted the planned sequence of events and contributed to the failure. But it's important to note that space missions, especially those involving complex activities like lunar landings, are inherently challenging, and even a small error can lead to mission failure. Despite the failure of the Vikram lander to make a successful soft landing, the Chandrayaan2 mission's orbiter has continued to operate successfully and has provided valuable scientific data about the moon's surface and environment. Lessons learned from this mission are the reason to make Chandrayaan3 most successful lunar mission by ISRO. On 14 July 2023, Chandrayaan3 mission is launched by ISRO for soft landing on the moon. Chandrayaan3 is launched to fulfill those objectives which were not done by Chandrayaan2. Landing area is made wider. Chandrayaan2 had to land in just the patch of 500 meter by 500 meter, but for Chandrayaan3 the area of 4 km by 2.4 km is covered. More fuel is given to Vikram lander so that it could suspend in atmosphere and could find the correct landing site. Softwares are updated so that lander can spin fastly. At this time, lander is not just limited to take photos. Chandrayaan2 mission is called as half successful mission because its orbiter is still working. The high resolution images taken by Chandrayaan2 are saved in this new lander so that it can decide correct and fair landing locations. Chandrayaan3 Vikram is the modified form of Chandrayaan2, but more solar cells and sensors are installed into it. The purpose of Chandrayaan3 is also landing on the south pole of moon and to place a rover. Now the landing location is 70 degrees south where large numbers of craters are present. This has always remained in shade so that it is considered that ice is present in these craters. When rover is placed over moon, then it has to perform all the experiments in just one lunar day. One lunar day equals to 1 month of the earth, which means 14 earth days and 14 earth nights. As the moon orbits the earth, so it also makes one complete revolution about its axis. This unique relationship results in the same side of the moon always facing the earth. The instrument present in Chandrayaan3 can't perform in lunar nights because in lunar night temperature goes down even up to minus 232 degrees Celsius. In such cold environment, any operators can't do any experiment. That's why ISRO chief has said that if we want its landing, then sun should be rising on the moon. Since that we will have a period of 14-15 days to work and collect data. And if landing would fail on 23rd 24th August, then we will wait for a month and will do in September, but fortunately it's done. Vikram lander weighs 1750 kg and rover weighs 26 kg. The rover name is still Paragyan rover. There are 3 modules of Chandrayaan3. First is propulsion module, second is rover module, and the third is lander module. With the help of propulsion module, lander and rover will be welcomed to moon's orbit and will be placed for landing in the radius of 100 km. There is no orbiter module in this mission because rover of Chandrayaan2 is yet working and will be used in this project. Propulsion module will revolve around the moon for 3 to 6 months. It will be used for communication purposes and for taking other readings. An instrument fixed in propulsion module named as spectropolarimetry of habitable planets Earth, in short form it is called as SHAPE. SHAPE will search for small exoplanets in space. Rover. Now the Paragyan rover has 2 instruments. First is LIBS, which stands for Laser Induced Breakdown Spectroscopy. It will analyze the chemical composition of lunar soil and will find out the materials present in lunar soil. Next is Alpha Particle X-ray Spectrometer. In short form, it is called as APXS. It will analyze stones on the moon. Vikram lander has 4 instruments. First is RAMPA, which stands for Radio Anatomy of Moon-Bound Hypersensitive Ionosphere and Atmosphere. It will try to melt some small stones on the moon through a laser beam and will analyze the gas released from it. Second is CHAST, which stands for Chandra Surface Thermophysical Experiment. It will measure thermal properties. Next is ILSA, which stands for Instrument for Lunar Seismic Activity. It will measure the moonquakes. Fourth is LRA, which stands for Laser Retroreflector Array. It will use laser to bounce signals from the Earth. With the help of LRA, scientists could measure the exact landing distance of Vikram lander and Moon's range. There are total 7 instruments, also known as 7 payloads. If that mission would be successful, then India will be fourth country in the world that will make the history of soft landing on the moon after America, China and Soviet Union.
From 23rd August to the next 14 days, many scientific experiments were conducted on the surface of the moon. The Vikram lander remained active for 12 days, but the Paragyan rover was put into a sleep mode on 2nd September. The Vikram lander was put into sleep mode on 4th September, but some of its electronic instruments, such as the input signal mode, were turned on so that Chandrayaan3 could receive signals from Earth when the moon dawned on September 22. On the 4th of September, the moon became dark and this lunar night was to remain so for about 14 days. ISRO scientists said that Vikram lander and the Paragyan rover were not designed to operate in the lunar night. If that were the case, they would have had to put heaters inside the lander and that would have required more powerful batteries. They believed that on 22nd September, the moon would start to see the sunrise, by which time its batteries would be recharged and it would come out of sleep mode. But even after 22nd September, the Vikram lander is not receiving any signal from the ground, nor it is sending any signal from its side to ISRO. It has been almost a week since the sun rose on the moon and still there is no good news of Chandrayaan3 waking up, and the question is starting to arise in people's hearts that the Vikram lander of Chandrayaan3 has not gone to sleep forever, and this mission is also a failed mission like Chandrayaan3. ISRO chief said, efforts have been made to establish communication with the Vikram lander and the Paragyan rover to ascertain their wake-up condition. As of now, no signals have been received from them. Efforts to establish contact will continue. On September 25th and 26th, ISRO tried hard to wake up the sleeping Vikram by sending signals, but they could not succeed in this effort. ISRO sent a signal to the Vikram lander with the help of the propulsion module in lunar orbit, but there was no response. Even the European Space Agency has tried to wake up the Vikram lander by sending a signal, but no response has been received from it. In addition, its artificial intelligence system was advanced enough so that if its battery is safe, it will automatically send a signal to Earth and wake up the Paragyan rover on its own. But after enduring temperatures of -200 degrees, even if it becomes active, it will not function as before. Now ISRO team has said that Chandrayaan3 will act as their ambassador on moon's surface.